Today we will see the problem 2.31 of the Griffith fourth edition Introduction to Electrodynamics. Problem 2.3 consists of two parts. Part A is three charges are situated at the corners of a square side A, as shown in the figure 2.41. This is figure 2.41. The diagonal vertices charges are minus q and here plus q. Then how much work does it take to bring the another charge plus q from far away and place it in the fourth corner? So now we have to find the uh, amount of work need to done to bring a positive charge plus q at the place fourth. See, this is first position and second position and third position. This is fourth one. Now, in order to find the amount of work done, we should know the potential. So, by definition, the potential is V of R is equal to 1 over 4 pi epsilon naught summation over Q I R I J. Here, I like to highlight one important point. R I J means it may be 1 to 2 or 2 to 1. So, that is a repetition. In that case, you have to divide it by 2. So you take only once, that is more than enough. Now we are going to calculate this potential at the point fourth place. Fourth place we have to find the potential. So that potential is this one. Um, we will see the term one by one. First, from point 1 to point 4, what is the potential? See, point 1 to point 4, one. This one is here you have minus q and the distance is the side is a. So that is minus q over a. Then to this point from 2 to 4, you take point 1 by 1. 2 to 4, this distance is, you know very well, it is square root of 2 multiplied by a. So that's what I have written. That is q divided by square root of 2 a. Here q is the positive charge, so I used plus. Then from point 3 to 4, that is from here to here. Here charge is minus. So minus q over a from this formula minus q over a. This is the potential. Now we have to find the work at place 4. We have calculated the potential. Now you can simplify this. See, everywhere there is q by a. I am taking that q by a outside the bracket. And here first term and the second term are the same. So this will become minus 2 q by a. Q by a we have taken out, so this will be just minus 2 plus this 1 over square root 2. This is the potential. Then work done to bring the charge q from far away to this position 4 is equal to, I am labeling that as uh, W4, which is equal to, by definition, the work done is equal to Q multiplied by the potential, Q times the potential. Here, Q is positive, so Q times the potential V of R. Here we have calculated V of R, which is equal to this one. You just multiply that by Q. So this will become Q square. Because here plus Q, I am multiplying by plus Q. So this will become Q squared over 4 pi epsilon naught A multiplied by minus 2 plus 1 over square root of 2. Now we will go to part 2. Now the part B is how much work does it take to assemble the whole configuration of four chargers, that is at the diagonal vertices here it is minus q, and this green color I have shown, this is the vertices of four vertices of the square. So these two green are positive charge. Now how much work we have to do to bring a negative charge? Maybe I will use a different color. So minus q here, minus q. So that work done here, there is no other potential, because there's the first I am bringing the charge minus q at this point. So there is no other charge. And naturally, the work done at this point 1. This I am labeling as usual. This is point 1, point 2, point 3, and point 4. So the there is no potential against it. So you can bring without any problem this negative charge. So naturally the work done is 0. Then what is the work done at point 2? Now the case is different. You have this negative charge. So I'm labeling that work done at this point is W2. Like W1, we have W2. So W2 is equal to Q V2, Q V2, which is equal to Q. Here you have a positive charge at this point, positive charge Q. Here you have a positive charge Q. So naturally, the Q times V2. V2 is this field, this potential. Now, due to this minus Q, negative charge. So that is minus Q divided by 4 pi epsilon naught A, which can be written as Q into Q will give you Q squared. Of course, there is a negative sign. So Q squared over 4 pi epsilon naught A. So this is the case. Similarly, now I am going to bring a negative charge here as usual. Now for this negative charge, there are two opposing poles. This field due to 1 and field due to 2. So now we will see the work done by work done at the point 3, which is equal to you can, I will explain this. First you take this point, then field potential due to this point minus q at the point 1 to 3. First we have to take the point 1. So this distance is equal to square root of 2 over a. So here there is a negative charge. So that's why I have mentioned here minus q v3. So now v3 is, I have taken minus q, then 1 over 4 by epsilon naught as common. Here the potential due to this point charge 1 to 3 is, this is minus q over square root of 2a. That is q by the distance. Distance is square root of 2a. Square root of 2 multiplied by a. Then there is another potential. This is due to the charge at position 2. So this is positive charge. Remember that. And distance is a. So this will be equal to plus q by a. Now here also you have q by a, here also q by a. I will take q by a as common. So this will become q squared over a, 4 by epsilon naught a. Here you bring this minus inside the bracket. So the first term will become plus. That is 1 over square root 2 minus 1. Now W4 at this work done by the to bring the charge Q at this point. This we have seen already in part A. We have seen it. So before that we will complete this square. This is what we got given in the problem. So the work done to bring this charge Q at this point is that we have seen already. Here there are two potential at point 1, 2, 3, which we have seen in the previous part. So simply we will take that result. W4 is equal to Q V4. So that we have seen Q squared over 4 pi epsilon naught A minus 2 plus 1 over square root 2. So now we have to find the total work that to be done to bring this charge Q. So now that is equal to work done at point 1, 2, 3. We have to sum up all these things. So we know this W1 is 0. We have seen W1 is 0. Only thing is you have to take W2 and W3, W4. Here you can see in W2 you have Q squared over 4 pi epsilon naught A. So in all three terms you have Q squared over 4 pi epsilon naught A. Here you can see there is a negative sign. So this you can take as minus 1 when you are summing up. This naturally will go to 0. Then W3, if we add W3, this is 1 over square root 2 and minus 1. Then this is minus 2 plus square root 1 over square root 2. Here you can see minus 1, minus 1 and minus 2 will become minus 4, and this will become 2 divided by square root 2. So the total work done is after simplification, you will get this q squared over 4 pi epsilon naught A, this minus 4 plus 2 over square root of 2. Now you bring 2 outside the bracket, then this will become 2q squared over 4 pi epsilon naught A multiplied by minus 2 plus 1 over square root 2. So this is the total work done. You have to do this much of work to bring the charge Q at position 4. Thank you very much for watching my video and supporting me continuously. Thank you very much.